Yes, we are live now. So, hey everyone, this is Vishal from Cipher School. Welcome to today's session on Docker for beginners. So, I'm assuming most of you are from a tech background, so you might have heard about Docker or containers before, right? So, but if you are very new to this topic that is Docker, then no issues. In today's session is designed for beginners, and you will understand the basic from very step, right? We'll cover each and everything by step by step. And to guide us through this session, we have Anshul with us today. So, welcome, Anshul. We are delighted to have you here. Please introduce yourself and take the session forward. Over to you, Anshul.
Hi, hi Vishal, how are you? And hello everyone. So I am Anshul, and I'm currently working as a SD mentor for Cipher School. I have 2.5 years of experience as a Java developer. So that's about myself. So yeah, let's start the session. So I'll be sharing my screen. Vishal, can you tell me where it's visible?
No, not right now.
Still not visible?
Yes, it's loading. Yeah, it's visible now.
Okay, so this session is all about the Dockers. So we'll see about why we need the Docker and how we can implement the Docker in a real world application. So before starting that, let's see the problem statement. Why this Docker has been introduced. Okay, so we'll see it is actually the one of the basic thing. Let's say we just normally say why this code is working on my machine, but it's not working on the other system, right? This is a classic problem. So we'll see how and why this problem occurs. So let's suppose there's an organization. There is an organization. Let's say there's an organization, and that organization is supposed having one simple a project. Okay, let's say this organization have a simple backend project. Now, this organization suppose hire a team of a developer. Now, let's say this backend project is not that large scale, so they hired a small team, or you can say just a one developer for now, and they in my future they might be able to extend the team. Okay, so let's say for now this backend project require a single developer. Now, we have a let's say this developer it's working on a backend project, and the configuration for this project, let's say it is using the Node version 18 and the database Oracle of 19c version, and the developer have a machine configuration as a Windows OS and the Intel microprocessor, right? So now it won't be any problem if it is working on a standalone project, right? Now, what if in future the client requests the organization that they want to have a multiple features, right? They want to have a multiple features. So now this organization now trying to expand their team. Okay, let's say they hired two more developers. This organization hired two more developers. Now, developer one was actually working standalone on a single project. Now, the organization tried to divide the workload in different different developers, right? So now this developer 2 and developer 3 wants to access the project, so they should have a machine, right? Let's say this developer 2 have a Mac OS and developer 3 have a system window, and in the Mac OS, they have a different version of a Node and Oracle database. Same for the developer 3. Now, this backend project, let's suppose this project has been saved in the GitHub repo. Okay, the system, this project is now at the GitHub repo. So this developer have pushed this code in the GitHub repo. Now developer 3 and developer 2 are trying to access this GitHub repo in their environment, okay, in their local environment. But there might be a chance this project or this backend project won't run because of the dependency issue. What dependency issue? See, this Node version is 10 version, right? And developer 3 have a node of 12 version. So there might be a chance this backend project won't run on their system. So to solve this issue, what the organization can do, right? If it is a small team, they can tell each developer to actually install the exact configuration which earlier developer one has installed in their system, right? Say Node version 18 and the Oracle 19c version. But the issue might be the platform because this developer 2 have a Mac OS and 3 have a Windows OS. So for 3 it won't be that issue, but developer 2 still holds the Mac OS system, right? So there might be a certain language barrier for the processors because the Windows is built on a different language and Mac OS is built on a different language. So there might be an issue of a platform. So to solve this issue, they might have a they might have to change their working station, right? But this works for the small team. Now what if this organization suddenly expand their team with a let's say with 100 developers, right? With 100 developers. So the thing is, you cannot do this manual installation of the dependencies. You cannot because it's not feasible. So to solve this issue, we have two maybe two solution. One solution is either either we can do the manual thing. We try to install each dependency manually on every system, but the platform issue still be there. So for the platform, what we can do that we can actually create a virtual machine. We can do the virtual machine. We can install virtual machine on each developer and try to install the same operating system. But still, a virtual machine will actually boot up the entire operating system. But let's say this your backend project is a simple, you can say simple student management portal. Okay, let's suppose this backend project is a student management portal. So this SMP student management portal doesn't require the full operating system power, right? It doesn't require. So why we actually it's not a good practice to actually load a full operating system. We cannot use the virtual machine for that because it is very slow first of all, and it takes a lot of memory. So it is also not feasible to actually install the virtual machine in every developer or those developer which holds a different machine like Mac OS or a Linux. So still the problem will be same. Now to solve this issue, there is another term called containerization. So what containerization does, right? So let's take this developer one. Let's say I have a machine called Intel processor and a Windows operating system, and I have a Node.js of 18 version and Oracle Dynasty. What containerization does is it isolate the entire machine. It isolate the entire machine and create the try to create a container of entire machine. Let's say this is your container. Try to containerize the entire machine into a container. So what container holds? This container holds it holds the OS power, not exactly the OS. It just hold the OS power plus all the dependencies, all the dependencies which this developer one workstation has. Let's say Node version 18 and 19c Oracle. Now this OS power means not the entire operating system, but just the snapshot of the OS, just a snapshot. So in the virtual machine, we are actually loading the entire operating system, whereas in container, we are just we are just sharing the base operating system of the system and just sharing the power of the OS, not loading the entire OS. So basically, this container will be lightweighted and will not hold the exact number of size as compared to the virtual machine. So this is lightweight as compared to the VM machine or VMware, right? So that's why container will be helpful if I want to work on a different team or let's say open source project. So what I can do, right? I can create the container of this developer one workstation and create the image of it. Now, what image we'll see later, I will create the image of it. By creating the container, I'll create the image of it So this image will later be shared with all the developers. All the developers, let's say this developer 3 will also be sharing this same image, and this developer 2 will also be sharing the exact image of the same container, right? Same container. So we'll see what are images and container later. So for now we can say that uh, why we need Docker, just to basically create the environment, uh, basically create the copy of the environment so that multiple teams can collaborate easily without worrying about the platform dependencies, or the you can say the normal software dependencies. So this was the problem statement that Docker or containerization solved. Now there is another comparison between the VM and containers. So basically, virtual machine basically loads the entire operating system, whereas container just built on top of the base operating system and just share the same kernel, whereas VM basically creates its own kernel for the operating system. And VM are basically not a lightweighted. It basically loads the full OS, so it will be very uh, the size of this virtual will be very large as compared to the containers. So where containers are lightweighted. So these are the comparison between the VM and the containers. Now there are another term of Docker and container. We are basically using the same term again and again. So what Docker is? Basically, Docker is a tool to manage, create, run the container. Okay, Docker is just a tool, whereas container are the real method, you can say, or real process of containerizing the entire workstation. Okay, so container is just the process of basically containerizing the whole entire workstation, and where docker is just the tool to basically manage the containers. Okay, so this is all about the containers, dockers, and virtual machines. I guess till here everyone till here, I guess it's clear what are Dockers and what are containers and where machines are. We'll see what are images and what are container. The difference between the images and container. Now we can map the analogy with the class and objects. So basically, the image just is the blueprint of the container. Now, what blueprint means? Basically, it holds the instruction of all the workstation, how workstation are created. Basically, it holds just the instruction. So we can say image is just the blueprint, blueprint of the container. Now, what are containers are then? So container is just the real instance of the image. Okay, we can relate the analogy with the objects and classes. So we can map the image with the class and container with the objects in the object-oriented programming. So basically just the real instance of the image. Okay, so we have seen what are Dockers, what are containers, difference between the virtual machine and the containers. We have seen the Docker image and container. Now there is another term, Docker and Docker Hub. Okay, so it is basically a Docker is just a tool. Docker is just a tool which create, manage, run the containers, whereas Docker Hub is a cloud platform where we can register our Docker image. Okay, it is just a store like a GitHub where we can create our repository and store the code inside the cloud platform. Same for the Docker Hub. We just store the image of the local containers. Okay, it is just a cloud platform where we can basically store our images. So these are the terms related to the Docker, and we'll see about the real world implementation, how we can basically create our own Docker and create how this real Docker solve the real world problems. We'll see later in the sessions, but I guess it's clear about the virtual machine and containers and Docker and the container, I guess. uh, and we can move on to the implementation part because it's going to be much easier. So before starting with the implementation, let's see what we need on our machine to start with the Docker. Basically, we need two things: Docker CLI and the Docker desktop. We can just Google it, the download Docker on Google, and the first link will be you'll see all the software which we need. You can download for your machine. I have already downloaded in my machine, so I can basically just directly start it. Okay, so just I can start Docker. uh, I have already installed my machine, so by clicking the Docker it will basically start the server. Now before starting the this Docker, I would love to also tell you about uh, these these mapping before going forward the implementation part, the Docker image and the container. Now why we need the image, why we cannot directly create the container. So basically we are not just creating the single container for the particular workstation, right? We are just not creating the simple container. Okay, so let's say we have different version of our code, right? Let's say we are working on version 1 of this student management portal, version 1. So we'll create the Docker image of it. Okay. Now what if in future the requirement says we have to work on the version 2, or let's say version 3. So let's say we have already have the image, so we can directly work on top of the image. We just need to expand our code. Okay, so we don't have to again and again write the code. If we have the version 1 image, we can build on top of the different versions, right? So this is why we need the image. We need the image. Same for the analogy of the class and objects. We need the class so we can create the multiple objects of the classes. Okay. So after, let's say, if you have downloaded this Docker desktop and Docker CLI, we can directly start with the implementation part. Let's say you have to first start this Docker desktop. You have to start with this Docker desktop. It will basically start. It says that it is up and running. So after that, you have to basically check whether you have the Docker CLI or not. To check this, write the Docker -v. I'll show you the version of the Docker. Currently, I'm using 29.2. So it will show you the Docker. Now, to see all the commands, you can type Docker -help or type Docker -help. So it will show you all the commands which we'll be using in this session. Now, I have told you this Docker use the concept of image and container, right? Image and container. And this Docker will create the operating system based on top of it image, right? We have different Docker image operating system for our Docker. These are the examples. These are the uh, operating system which enterprise already created on the Docker Hub, which like Alpines, Debian, Ubuntu, Fedora, etc. Right? These are the operating system, or you can say the light operating system, which are already been created by the enterprises for our, so that we can directly use these you can say images in our code directly, right? We'll see about the Alpine and Ubuntu. Let's see this Ubuntu Docker first. Okay, we have the Docker. So what we can do that we can directly say docker run and -it and name of the operating system. So let's start with the Ubuntu. We can directly write Ubuntu. Now this IT means uh, it interactive mode. I want to interact with my Docker container, so I have to write this Docker run -it. So if I type this, see, we are now have our own container, and inside our container we have the Ubuntu operating system. Now we can type all the commands like ls, it will work. Okay, we can also type the host name. We can also type who am I. I'll show you the user, the host name, and the all the file system, because we are directly having a connection with the Ubuntu operating system. But don't get confused. This Ubuntu is directly loading in our operating system. Basically, this Ubuntu is coming from the Docker Hub. We are pulling this image and we are just running the Ubuntu, and the operating system, this Ubuntu operating system, is just sharing the same kernel as my Mac OS. Okay, it is not creating the entire OS from scratch. It is just sharing the sharing the same kernel as my macOS. Okay, so we can have we can install all the dependency, but you can see if I try to check whether node application in my system is or not, you can see there is no node, right? And if I go to my macOS and if I type node, you can see there is a node application, right? So how can we actually interact with our how can we basically run our application inside this Ubuntu, because this doesn't have any node application or the npm packages, right? So for that, the enterprises have already created the different you can say images for our requirement, right? We'll see later in the implementation part. Like we have Node 18 Alpine, we have Ubuntu Alpine, we have Debian Alpine, different operating system uh, images, right? We have already there. We'll see the implementation part later. But this was just the basic, you can say basic container. We have basically run this container in our operating system. Now let's start building a simple application, simple node application. We'll try to do the containerization part there. Let's say we have this. I have already written the code. This is the basic server Node.js application, Node.js plus Express application. We have loaded the Express Express module. We have the let for now. Let's just delete this. We have the let's say port. For now, let's take this port as 3000. We have a basic gateway, and we are listing this gateway at port 3000, right? So for now, I have to also install the Express in my project. I can load this Express module. Now, if I start this, if I run my application and give run start, you can see this currently application is running on my port 3000. Okay, so we can see this application is currently running. Okay, and this is just a basic application. Now we this application basically have three things. Okay, one is we have a Express module. I have node I have a node dependency. I have Express module, and I have, you can say, I have an npm dependency as well, right? And on top of it, I'm using the macOS macOS on my system, right? I have three dependency and one platform dependency. Now, this is a very simple application. If you try to run this code in other system, this might run. But let's say in real world application, this is not going to be as simple as this example. It might be a complex code. They might be have a multiple dependencies. They might be have a multiple, let's say, microservices, right? So there might be a chance your code might not run in different system. So to resolve that, we're trying to containerize this whole application, right? Containerize this whole application. For that, I have told you, you have to create the image of your workstation, right? You have to create the image of your whole entire workstation. Okay, now we'll see how we can create the image. I have already told you, we can run our container using the Docker tool. So we have to use the Docker in our project. We have the CLI, and we have the desktop, and our Docker is also running. You can see it is also running. So to create the Docker, we need to create the Docker image, and for Docker image, we need to create the Docker file, which is very important. Docker file. Okay. So if I want to create the Docker, I need to create the Docker file, Docker image. I need to create Docker file. So this Docker file follow certain you can say steps. So you have to specify all the necessary information for creating the Docker image. We'll start with the from. Okay, so this from is the reserve keyword. You have to use it, and you have to specify which operating system you want to use in your application. Okay, you can use Mac OS, you can use Windows, you can use Ubuntu, anything. I have already told you. If I try to install the Ubuntu operating system, this might not run because Ubuntu does not come with the Node, Node, Node. You can say Node.js. It does not come. So I have to use a different operating system, or I have to install the Node.js from the scratch. But the enterprise have already provided us with the uh, different you can say operating system. So there is a famous operating system, node 18 alpine. Node 18 alpine. So this node 18 alpine will provide you the this node 18 alpine will with you the provide with you the alpine. Alpine is the operating system, like the Debian, Ubuntu. Alpine is the operating system. This node 18 gives you the node.js 18 version. Okay, this node.js this node 18 will give you the node.js 18 version and the alpine operating system, and this will also consist node.js alpine alpine os and npm package. Okay, this comes with three things: the Node.js framework, Alpine OS, and the npm dependency. So I don't have to worry about the Node.js and the operating system now. Okay, I have already mentioned. Now, also I have to tell the work directory. Okay, work directory. So for now, let's assume I'm just creating my container inside the app directory. Okay, inside the app directory. Now I have to copy few things. I have to copy few things which are package.json. Okay, why package.json? We'll see later. But for now, let's assume I'm using package.json in my container. Okay, this is for the container. First, I'm trying to load the operating system node 18 alpine. Then I'm trying to create the working directory inside my container, which is app, and then I'm trying to load the package.json. Okay, now after that, I want to install the, or you can say run the command, which is npm install. Okay, this will basically install all the dependency which my project have. For now, it is just have express as a dependency. So this Docker file will install the express in my container. Now, after installing express in my container, I want to copy everything, which include the server.js, Okay. Now after that, I have to start my server. So I have to specify the command. The command is npm npm run and start. So this was the command which start my you can say server. Also, this might not work because in my package.json I haven't specified the script. Okay, I haven't specified the script. So first let's delete this package.json. We'll try to basically create the boilerplate for this. So we're using npm init. This will create the boilerplate for my package.json file, and then I will install my express. So this basically install the express in my working station. Okay, now if I open my package.json, you can see I have the express JS in my dependency. So basically, it include all those dependency, and also the start script which is required, node server.js. Now if I try to, let's say, npm run start, so you can see this port is now running fine using this command npm run start. Okay, so this start will be run, and this will basically run the node server.js, which is the file name. Okay, now this Docker file will will run perfectly fine because we have actually mentioned the script in my package.json. Now this is all about my Docker file. So using this Docker file, we can create our Docker image. Okay, using this Docker file, we can basically create our Docker image. Okay, So we have seen about the we have seen about the uh, containerization. We have seen about the Docker image, and we have seen about the uh, how why we need the image and container and virtual machine. We have also seen about the why a virtual machine is not the best option uh, in a small application. Why containerization is important. We have seen about that. Now, for creating the image, we have seen why how to create the image using the Docker file. Okay, so this is the you can say this is the boilerplate of creating the Docker file. So first you have to mention which operating system. Again, second step was you have to specify the working directory. For now, I have used the app. Then you have to copy the package.json. In the Node application, you have to copy this because all your dependencies are written inside the JSON file. Now, after that, you have to install those dependencies. For my case, it was express.js, and after that, you have to copy the server.js. You can either directly write the server.js, but in the large scale application, there might be multiple files. So that's why I've used dot twice. Okay, now after that, you have to run your application by specifying the which command will run your application. So for different languages like for Spring Boot or let's say for the Python, it might differ. It might differ. For a let's say for a Java Spring Boot application, you have to run the jar file right using the JDK command, and for the Python, it might be using the pip or Python tree. So it differ depending on your framework, right? Now we have this Docker file. We have this Docker file. We can create our Docker image using this Docker file. Now, how to create our Docker image? It is very easy. Just you have to specify. Just you have to specify Docker build hyphen t, Docker build hyphen t, and tell the image of your. You can choose any name for your image. Let's take test one. This is the name I've chosen for my, or you can say, let's say, test YT one. Okay, test YouTube one, and you have to tell in which directory your Docker file is there. Okay, for now, uh, let's check whether I am in my current directory or not. Yes, I am in my current directory. So I can basically directly tell Docker build my Docker image using the Docker file, and name my Docker image as test YT1, and my Docker file is inside the same directory by telling with a period symbol. Okay, if I hit this command, it is currently failing. We'll see why it is failing, because uh, I guess we haven't saved this. Yeah, we haven't saved the Docker file, and you have to also save this server.js as well. Okay, now now you can see my Docker image has been created, and you can see the step as well. I have 6 step, right? See, in a first step, my operating system has been loaded, right? You can see node 18 Alpine has been loaded. Now in a second step, my working directory has been initialized, it has been cached. Now in my third step, I have copied my package.json in my container in my image, or in the fourth step, I have installed all the dependencies, and then I have copied all the extracted file. Now this sixth step is for the when I'm trying to uh, run my container. Okay, this sixth step is for that. So I have created my image. Now to check whether my image has been created, just type Docker images. See, I have my test YT1 image already created, and you can see the size of this image. It is 47 MB. It is 47 MB. Now it is far less as compared to the virtual machine. If you create your virtual machine, this might be in GBs. Okay, this might be in GBs. This is far better than creating the virtual machine. Now I have the Docker image in my system. Now to run my Docker image and act as a container, or you can say create the container, the syntax will be docker run docker run hyphen P. This is for the port. Okay, you have to specify the port. We'll see the port mapping later, and you have to tell which port number you are running in your local machine. So see, I am running 3000 port. So you have to tell 3000 port and a colon. Then you have to also specify the container port which your application might run. So again, I'm using the same port number. Then you have to tell the image name. Okay, so image name is test one, test yt1. Okay, this is my image name. So this command will run the container in your local machine. So for, let's say, first we can see whether my application is running or not. You can say it is not currently running. So after creating my container, you can see the server is running on my port 3000, and you can see it is currently uh, running, right? My application is live on port 3000. Okay, so this is how you can create the container and run the container by using the command docker run -p. You have to specify the port. Okay, so we have seen how to create the docker image and how to run the docker container. Okay, now there might be a few more syntax of creating the docker. We'll see later. But for now, just assume this Docker syntax is important and run has to be specified, and this port number need to be written and the name of the image. Now let's see my container has been built or not. So you can check how many container in your local machine by writing the command docker ps. See, I have only one container. I have only one container which is running. So this command is for uh, checking which container is currently running. Okay, you can see this container is running. I have I've made this container run. So now I have exited this container. Now after see, you can see that Ubuntu container is also now in offline mode. Now to check how many containers are in my system, you can have to specify this flag -a. See, I have these number of containers. Test YT1, Ubuntu, Node 18 Alpine, Node -18 Alpine, and Ubuntu again. Okay. See these number of containers in my machine. And the name of my container is Gracias Discord. So this is the random name. You can basically rewrite the name at the time of the creation. You can basically change that. We can see how to change the name of the container. Now you can see this container has been created in my system. Not This is in offline state, right? This is in offline state. Now to run this container, you have to just type docker docker start and the name of the container, docker. This is the name of the container. See, now my docker is running. To check whether it is running or not, just type docker yes. See, it is now running, right? This container is now running, and we can see. Now to stop this container, you have to use again same command docker stop name of your container. So this will stop the working of the container. Okay. So this is how you can control your container. You can control your image using the Docker tool. Okay, so Docker is just a tool for managing the containers. Okay, you can manage your container, and you can even create multiple container inside your local machine. We have seen just the one, but we can have the multiple container running at a single time without basically having the multiple operating system in my system, right? I don't have any uh, don't have multiple operating system right now. I have just the Mac OS, right? So even having a single base operating system, I can load basically multiple container. That's the beauty of the Docker or the containerization concept, right? So we have seen how to create the image. We have seen how to create the container using the Docker image. Now let's see few more commands for the Docker, right? So first, let's see how to delete the container. So first, see which container are in the running state. So there are no container in the running state. So you don't have to stop the container. You can basically just type docker ps -a and see. I want to delete my this container. So to delete this container, you have to specify docker rm, which is for remove, and the name of the container. So this will basically remove my container. Now, if you see docker ps-a, there is no container name with an image test yt1. Okay, now to remove the image, so let's check the let's first check how many images we have. We have these number of images. Now I want to remove my test YT Docker image. Now to remove the image, just type RMI, just stand for remove image, and type the name of the image. So which is test YT1. So basically this will remove the image in my local machine. Okay, now I want you to uh, basically just I want you to know about the concept of port mapping. Port mapping. I have written about the port mapping as well. See, there are many concepts which are how to run a Docker. We have already seen how to create a Docker file. We have already seen how to build a Docker image. We have already seen. Now there is a concept of port mapping. See, uh, if you want to create the Docker image, first you have to basically tell Docker build -t and the name of the container. Let's say again test yt2. So this will test yt2, and you have to specify the base. So this will basically create the Docker image. Okay, you can see test yt2 has been created. Now to again run this container or create the container, you have to specify docker hyphen b port 3000 colon 3000. So you can basically change any port number in your local machine, right? You can change any port number in your local machine. So if I want 4000 and let's say 3000, so basically this means that your local application should run on port 4000, and inside the container it has to be run on port 3000. Okay, so this will basically run your application on port 4000. So this is the concept of port mapping. And why we need port mapping? See, let's say in our system we have multiple containers, right? We have multiple containers. So you cannot run all the application on the same port. You have to specify different ports for your different containers, right? So this is why we need the port mapping concept, so that we can change the port number accordingly. Okay, so this is all about the port mapping. Now there is another flag D hyphen D. This is a detachable port. Sorry, this is a detachable concept. If you specify this and try to let's say run your Docker container, you have to you have to specify the image name, right? Now I want to change my Docker name by saying hyphen name. Let's name this running test yt2, and you have to now specify the name of the image. This is the name of the image. Now using this flag, this will basically rename your container name, and this flag means it detach your container. Now detach means it will run the container in the background. Okay, so this will not interfere your terminal. It can basically run your application in the background mode. Hyphen D is for that. Now hyphen name is for just changing the name of your container. Now please remember, your image name and container name will be different. Okay, even if you don't specify this hyphen name flag, it will basically give your container name some random name, right? We have seen earlier we have seen that it basically choose the random name. So to specify the name, you can use hyphen name flag. Now let's create the image. It is for yeah. Okay, let's basically first see. Uh, so Docker hyphen p for the port. Let's map this port to 3000, and let's name our Docker image to running test, and my image name is test yt2. Okay, so okay, you have to also specify the run command, right? I forgot. You have to also specify the run, and you can even use the detachable. Now, see, now this test yt image has been created with the container name running test. We can see docker docker ps. See, now my docker running will have a name also, running test, and this is now running in the background. Okay, this will run in background as well. So even if you close the terminal, this application will still run. Okay, this application will still run because you have used the detachable flag. This will basically run your application in the background itself. Okay, and even you have changed the uh, default name of your container. Now its name is running test. You can even stop your container by just typing the name of your container running test. So this will basically stop. Even you can start uh, your container. Now to check the logs of your container, you can use the log. This will basically tell the log of your application. Right now, this will not show you anything because uh, your application is still not running. Okay, so this will not show. So if your application is up and running, it will show the logs or the errors if your application having. So that will show. So this is all about the creation of the Docker and Docker images. Now let's see what if in our application we have environment variable. Okay, environment variable, just a small flag. Let's say my application suddenly requires to have a environment variable. So for that you have to basically load the .env file, require .env. You have to require this and config this. Okay, now suddenly my application use this, and instead of using the port number, I'm using the I'm using from the uh, environment variable. Okay, directly from the environment variable. Now, if you run this application, if you run this application, let's say I have this environment variable in my system, port equals to 3000, and if I run my application normally, npm run start, see, uh, okay, you have to also install the .env dependency. Okay, it is also a dependency. You have to install this dependency first. Now if you run this application, now it will run. See, this is running because you have mentioned your port in the environment variable. Now what if I delete this, I have deleted this, now let me first also delete my old old container. Let me first delete this old container docker. Remove running test. I have deleted this. Also, I have to delete the image of this, which is test yt test yt2. Okay, I have deleted this image as well. Right now, I have to create the image from scratch again because I have made changes in my code by adding the dependency and by adding this piece of line. Okay, this piece of line. So again, I have to use command docker build hyphen d, and again I have to tell the name of my container, which is test yt, and the working directory, which is the same directory. Now I have created my Docker image. Now let's create the now let's try to build and run my container. Now see, I have used the environment variable as a dependency. I am trying to access this environment variable, and see, I don't have the env file in my system, right? Now if I try to run and build the container by, let's say, docker run hyphen port, let's say 3000 and 3000, and let's run this by also naming this running test, and the name of my image is test yt. See, you can see now this won't run. Now this won't run. Why? Because I don't have this local environment in my application. Okay, So two, if your application does have this local environment variable, so how you can pass this? So you can pass from the Docker file. You can pass your environment variable from the Docker file like this. Okay. Or you can pass your environment variable from the build from the build itself, right? From the build itself. We see how to pass this from the build. Now, for that, I have to basically delete my container again. So, for deleting the container again, Docker RM, and before that, I have to kill my container running test. So this delete my container. Now again, if I try to create this container by docker run hyphen e, so this flag is for the environment variable. Okay. Now I am trying to pass the port. Okay. Now if I try same command again, 3000, and let's name this again running test, and the name of the image which is test yt. See, now this application will run, right? This application is running. Why? Because I have mentioned the environment variable from the build itself. Okay, from the build itself. Now, what if you have multiple environment variables? So you can either specify from the Docker file, or you can basically implement or basically specify your environment variable in a single line, or there is another command which is for the entire file of environment variable. So you have to say env file. Okay, and env file, then the name of the environment variable file. Okay, so this is how you can basically specify how many environment variable you have to pass. So this is all about the containerization. Now, how to basically upload this Docker image in the cloud platform. See, I have this my cloud platform already running in my system. Uh, See, this is my repository. For now, I have two images. So before starting that, you have to basically do some configuration, which is Docker login. You have to first log in with your account. I have already logged in my account. So just specify the Docker login, and it will redirect with you with the Google account, and it will automatically authenticate your Docker account. So after that, you just have to basically uh, let's first check my Docker image. Okay, let's check my Docker images. See, I have the image, and I want to insert this. I want to push this Docker image in my repository, right? So how to insert this? There's a two-step process. See, first you have to specify the tags. So how to specify the tag? See, Docker tag your username. My username is Riddler9, and this forward slash and the name of the Docker image. You have to first tag your uh, Docker image. So this will tag your Docker image globally. Okay, so for this you have to use the Docker. So for this, you have to first basically check whether your instance are running or not. So we'll see Docker PS. So yeah, instance is not running. Again, we'll see Docker images. My images is there now. Docker. There is a command for the tag as well. Docker tag. Yeah, I can basically specify again Docker images, and I want to tag my Docker tag. I want to tag using this account Riddler, and let's say latest. Docker. Okay, so basically you have to first specify the tags before basically pushing the request in your Docker GitHub. Now for the tag, basically you can create the readable name. Let's say in my, let's say test one I've already created. This is the tag for my uh, test one Docker image, right? Now for creating the exact tag, you can basically just first check whether this images is not clashing. I guess it is clashing with some name. Test YT. Now let's tag this as well. Docker tag required two arguments. Test YT. I want to tag my test YT with Riddler, Riddler 9, and test YT. Okay, yeah. So basically, you have to specify the source as well. Which source, your which local image you want to tag, and with the cloud tag. So this is my username. I have tagged this. Now, if I try to do list of images, you can see, I have my Riddler 9 hyphen test YT already tagged in my local. Now this is in my local. Now to basically push my image in the cloud platform, you just have to do pull docker pull, and the name of the uh, tag, which is Riddler 9 hyphen test YT. Oh, okay, oh, you don't have to also specify the latest. It is not resolving. Okay, you have to, sorry, push this, not pull. Pull is for the retrieving the data. Pull is for the retrieving the data. Pull is for basically pushing your changes in the cloud platform. Now see, I'm pushing the changes in my cloud platform, and this image will basically used by all the let's say if you're working with a collaboration, all your team members can access your images. Now if I refresh this page, you can see this test YT is in my repository, right? Now if someone wants to use this image, they can basically copy this URL, and by copying this URL, they just have to use this command docker pull and this Riddler, my username, and the name of the image, name of the image. So this is how basically they can pull the image of someone workstation, right? So this was all about the creating the Docker and pushing the changes in the cloud platform. Now if you have any doubts, you can basically write in your comments, or you want to know about the, let's say, topics about relating to the containerization. If you have any doubts, you can basically ask in the chat box. I guess we have seen how to create the image, how to push changes on the cloud platform, and even we have see the single application. This is a single page application. How to push the changes and basically containerize inside the containerize this whole application in the image and try to basically run inside the container. We have seen also that. I guess we have covered all the basic concepts. And if you have any doubts or any, uh, you can ask.
Yes, Anshul, from my side, I would like to ask two questions. Then we'll
Okay.
wrap up the session.
Mm-hmm.
Uh, yeah. So the very first is what are the common mistakes the beginner should avoid when starting with Docker? And the second is कि अगर कोई स्टूडेंट अगर डॉकर को और एक्सप्लोर करना चाहता है इन मोर डेप्थ, सो व्हाट शुड दे लर्न और प्रैक्टिस नेक्स्ट?
Okay, so for the first question, basically, what they do that they think that whenever they are, let's say, creating the application, right? They think it's a very small application. Why do we need the Docker, right? Why do we need? So they don't basically containerize their application. So what I recommend that even if you are making a single page application, just try to do containerization concept because it will help you clear the concept. And let's say they are using the let's say single application, and by adding the single base operating system, right? Let's say they are having at the Ubuntu operating system, so which is
Mm-hmm.
not a good practice. You have to decide which, let's say your application have only three dependencies, so you have to basically do the research. What type of operating system is basically suitable for my application? So you have to basically decide that you cannot basically load the entire bootstrap operating system in your application. So these are the common things, and if they want to explore more, I would suggest that basically they can start creating every let's say they have a 10 application in the GitHub repo, that please try to containerize all your application, because this will help you get familiar with the commands, and try to basically push your changes in the cloud platforms such as Google Cloud or the AWS.
Mm-hmm.
So this will help you familiar with how in the industry they try to basically work in the collaboration with these cloud platform like AWS and GCPs.
True, true, true.
Yeah,
So that's all for today's session, everyone. And thanks, Anshul sir, for this session and for
thank you.
explaining Docker in such a simple way possible. And we hope you learned something new today and got a better understanding of Docker and the containers. So, one important announcement. So the quiz link will be shared shortly on your WhatsApp channel, and it will remain active for the next 60 minutes. So please make sure to submit it before the deadline, right? And also, don't forget to share your valuable feedback with us, right? Yeah. So thank you all for joining us today. See you in the next session. Until then, take care and happy learning. Thank you so much, Anshul sir.
Yeah.